What we're going to do now is talk about parametric equations. Parametric equations one thing it allows us to do is graph some things that maybe in our regular y equals function of x equations are not as easy to graph. That's what parametric equations, one thing it allows us to do. And other things, there are other reasons for considering parametric equations. But that's what we're going to talk about a little bit. First of all, we're going to call what we've been mainly most often dealing with are y equals, like I said, functions of x. And let me just put one up here. X cubed minus 7x squared plus 5x minus 3. I mean, a very simple equation. I mean, we've dealt with a lot more complicated ones. But nonetheless, what we're going to call those now, since we're going to deal with these other types of equations, parametric equations, is we're going to call the types we have been dealing with, we're going to call those Cartesian equations. Instead of just a function of x equation. We're going to call it a Cartesian equation. And parametric equations, what we do there is actually instead of one equation to kind of, this, if you think about the graph, this just defines, it gives us a set of points, right? X comma y's. Plug in an x, you got a y. Well, we define solutions to the graph or whatever we're going to do. In parametric equations, we use two equations instead of just one. This relates y and x. And the reason they're called parametric equations is because we're going to have an x equation and a y equation, and those equations are going to be in terms of another variable, and that's called the parameter. So here's an example here of a parametric equation. It's two equations, so we got an x equation, called parametric equations because it's two. X equal t squared minus 2t, and then we're going to define the y, so we're still going to have x, y points as far as solutions goes, but it's also in terms of a t plus 1. So t here is the parameter. And that, like I said, it gives us a way to graph. You'll see that we can do some wild and crazy graphs, but the other thing is t makes you think of time, doesn't it? So this, a lot of times you can define where x is in terms of a time, and then y also in terms of a time. So that gives us a way of doing that also, these parametric equations. Okay, that's another reason. But anyway, t is called the parameter because x is in terms of t and y is in terms of t. And so give me a t value, and I can tell you what the x, y is just by plugging in that t value. Okay, and that's what we're going to do. We're going to start by graphing these parametric equations and look at the graphs that we can generate, different ones. But anyway, so in general, here's the way we'll define it. Yeah, parametric equations. You got x equals some function of t, and then y equals some function of t. And of course, they don't have to be the same one, function of t. So you got two instead of one. T can be thought of as a time. It can be thought of as an angle. Sometimes we'll do t as, instead of t, maybe an angle like theta, something like that. But it can be angles or distances, something like that. So let's start here. Pretty simply, just sketch the graph here that we generate. X equals, so it's the same one, t squared minus 2t, y equals t plus 1. And then added to this, we're going to have t values between -2 and 3. So t is less than or equal to, -2 is less than or equal to t is less than or equal to 3. We're going to sketch this graph. All right, now, it's a good idea here just to get used to this. We'll talk about the calculator. The calculator can definitely help us on this, but let's go through a couple of them just to get the feel for how all this works together. So when I do a table, I got to have 3 columns here because I've got to first of all do the t. That's my parameter, and it's the ones that I choose the values for, if you will. And then the other part of the table is the x value and the y value, which x here is t squared. Just put it right here. X equals t squared minus 2t, and then y equals t plus 1. And since t is going between -2 and 3, let's just kind of go by ones. Start at -2 for t, and then -1, 0, 1, 2, 3. You know, if it looks like t is more of angles, then you might do something other than integers, maybe pi over 4s or something. But anyway, well, I think I've got one of those. I'll do that a little bit later. Yeah, so then it's just a matter of plug those in. -2 for t, so it'll be 4 plus 4, that'll be 8. Right? Did I do that right? And t is -1, so -2, so the y value would be -1. So that gives me the point 8, -1. So it's the same. I mean, we're still graphing these on the x, y axes. So it's still, this just generates an x, y point. So just go through here. T is -1, that'll be +1 plus 2, that'll be 3. The y value would be 0, -1 plus 1. So that'd be 3, 0, point. 0, that's easy, so 0 is 0. T is 0, so x is 0, y would be 1. T is 1, so that'd be 1 minus 2, it'd be -1. 1 plus 1 is 2. T is 2, it'd be 4 minus 4, that'd be 0, wouldn't it? And then t is 3, so it'd be 9 minus 6, that'd be 3. 3 plus 1 is 4. Did I do those right? It's okay. So let's fill it. So I got 0, 1, -1, 2, 0, 3, 3, 4. We just plot those points, see where you go. All right, so we got out to 8, -1. 3, 0, 0, 1, -1, 2, 0, 3, y-axis, and then 3, 4. So just plotting a couple points. Now, you kind of get the idea, connect those up. And because of the nature of these things, they also tend to indicate, so we started right here and went to here. So for this one, this would be, of course, our initial point. This would be our terminal point. For obvious reasons, you can see why. We started at -2, at 8, -1, and then we finished off at 3, 4. So that's hopefully obvious why we call those that. But they also tend to indicate the direction, because with these, I mean, you can get them go in all kinds of directions. It doesn't necessarily go the way, I mean, it could go, you know, it could start here and go here. So with these, so anyway, they typically indicate on these parametric equations, graphs, which way things are going, which way they're flowing. Show the direction. Okay? All right, let's do one more of those. Then we'll talk about doing it on the calculator if you don't already know how. All right, so let's sketch x equals cosine t, y equals sine of 2t, and t is going 0 to 2 pi. This was fun. Yeah, so like we said, t, you can think of that as time. But in this case, we might want to think of it more as an angle. And so that, and going 0 to 2 pi, that also suggests here, instead of doing integers, we might want to do pi something or another, right? I think I did, so we're starting at 0. And I did it pi over 4, just to give us a good, pi over 2 may not be quite enough. So go by pi over 4s. So 1 pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and then 8 pi over 4, which is 2 pi. So we just step by pi over 4s. Okay, so t is 0, cosine 0 is 1, sine of 0, 0. Cosine of pi over 4 is square root of 2 over 2, which is about 0.707. And then sine of, well, if you do 2 times pi over 4, that'll get you sine of pi over 2, which is that 1? And that's 1. Anyway, you know, just whatever you have to do to figure all that out. All right, so the next one's t equals pi over 2. Cosine of pi over 2, that's 0. Sine of 2 times pi over 2, that would be sine of pi, which that's back to 0. And then just keep going. Save time, I'll just cut to the chase here. I've got them written down. Yeah, this would be a negative square root of 2 over 2, negative 0.707. This is negative 1. At pi, I've got negative 1 and 0. 5 pi over 4 is negative 0.707 again for x, and 1 for y. 6 pi over 4, 3 pi over 2. No, 0, 0. 7 pi over 4 is 0.707 positive, and negative 1. Is that pretty level? 2 pi is 1, 0. Let's expand this out a little more. Because you'll notice our values are really trapped between positive 1 and negative 1. So I'm going to make my scale a little bigger than I normally do. Let's make that a half. That's 1. This will be a negative a half, negative 1. Yeah, because we're in there pretty close. All right, so 1, 0. Where do we start? Right here. X is 1, y is 0, so that's right on the x-axis. Then I've got 0.707 for x, right there, and then positive 1 for y, so it's up here. And then we're back to 0, and then we come back to 0, 0. And so you might want to, so here's what happens. From there to there, it's kind of going like that. All right, then we're at negative 0.7, negative 1. Okay, so it comes back down to here. And then negative 1, 0, negative 0.707, positive 1. So yeah, you can see it's starting, and then it comes back to 0, 0. and then positive 0.707, negative 1, and then back to 1, 0. Infinity. That's how you do infinity on a graph. Little parametric equation. Interesting. Anyway. All right. Now, like I said, do a couple of those by hand, fill in the table and stuff. But the nice thing is, graphing calculator helps out here. Graphing these two. All you have to do on a graphing calculator, TI's, probably Casio's, yeah. Also, is change the mode. And on the TI's, mode is TI 83, 84. Mode's right there by the first, well.
By the second.
By the second button, yeah. Just go to mode, and then it's got a line. Mine has, it's in function mode. That's the regular y equals mode, y equals function of x. But then the second one is par. The third one is pole, which we'll talk about polar next after we do parametric. And then sequential, that's another deal. But yeah, this one, parametric mode, right there. If you switch it over to parametric mode, what that does is then if you go to your y equals screen, lo and behold, you got an x1 and a y1. So you can plug in your x1 and your y1 there. So let's go back to this one. Do this one first. All right, so that would be x1 is t squared minus 2t. And then, so yeah, if you hit the x button now, it turned it over to t's automatically on the TIs. If you have a Casio, maybe. Little.
Wait, when you plug in the exit? Oh, okay. Yeah, it did.
Yep. Just hit the X button and it'll do that one automatically. Or you can do the alphabetical T too. But the other thing though is to get it, this particular part of it, once you get those X and Y entered, you also need to go to format. Not format. Window. I'll get it right here. If you go to the window on the TI-3s anyway, if you go to the window, or you guys have different TIs than me, but hopefully similar. But yeah, you can set it. I think default it sets the minimum T to be -10 and the maximum T to be +10. So you can just change those to whatever you want, -2 to 3, and it'll show you the part of graph you want there. And then hit graph. Yeah. So it shows our little fish hook there. You did it right. And then you can also use the table feature then to help you out there. Does everybody get it? And then try to get your, do the same thing with this infinity graph.